Okay, the video that you guys requested on exponents. I'm not rewriting out the exponent laws. I think everyone in grade 10 should know the exponent laws by now. Okay, what we're doing for this one here, it's addition and subtraction. Where's my marker? Since it's addition and subtraction, I want you guys to highlight the addition and the subtraction so that you do not forget that it's there. Okay, we want to get them into prime bases. Prime bases, you use the shift fact button on your calculator, and if you notice here, prime base, 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 so I don't have to shift fact anything. Okay, what I like to do is I like to separate them like this: 2 times 3 to the x plus, just so that it makes it easier for me and I don't forget anything, right? So 5 times 3 to the x positive 1 minus 7 times 3 to the x to the negative 1. Let's highlight my positive, my plus sign, and my minus sign so that I do not forget it. Because there's a plus or minus sign, it means that I can't cancel this 3x with this 3x and this one with this one. What it means is I have to take out the highest common factor. So my highest common factor, let's highlight. Let's use this marker. Can you see there's a 3x here, 3 to the power of x here, 3 to the power of x here in the denominator. The one that you take out in the numerator can be different to the one in the denominator, okay? But in most cases, you're going to see it's the same because we want to cancel them. 3 to the power of x. If I took out this, I'm left behind with just a 2. There's a plus sign. I'm left behind here with a 3 to the negative 2. Remember, if there's nothing left behind here, you would put a 1. Okay, if I take out this 3 to the x that's common here, I'm left behind here with 5 times this 3 minus 7 times 3 to the negative 1. Okay, now that this is multiplication, can you see this multiplied by this multiplied by this? Okay, so even though there's a plus and a minus sign, but they're in brackets and it's now multiplication, I can now cancel this one with this one. If your instruction says without the use of a calculator, then you're going to use your normal fraction rules, okay, like how you would do in grade 8 and 9. If it doesn't say so, you type this whole thing on the calculator over, you type this whole thing on the calculator, and then you put the thing on your calculator and get an answer. Okay, I'm going to do this first one as if it's said without the use of a calculator, just so you know what I'm doing, and then the rest after that I'm going to show you with the use of a calculator. So this here would be 2 plus, this is 3 to the power of negative 2, which means it's in the denominator, and the denominator is going to be 3 to the power of 2. Yeah, I said 3 to the power of 2, I meant 3 to the power of negative 2 when I was reading my question. But anyway, 1 over 9 over 5 times 3, 15. This here is going to be minus 7 over 3. The 3 goes to the denominator. Okay, let's continue. Because this is addition of two fractions, it's going to be same denominator because LCD. This one here is currently over 1. We want it over 9, so multiply by 9, so giving me 18. Got an equal to sign. This here is again also over the same denominator, so over 3. Over 3, this one was over 1, so multiply by 3, so 45 minus, what's that, 7. Let's work this out. 18 plus 1 gives me 19 over 9 over 45 minus 7. What is that? My brain can't think right now. 40, okay, 38, sorry, brain couldn't think. 38 over 3. This here is fraction divided by fraction, so that is depend times 19 over 9 times 3 over 38. 3 goes into 3 once and into 9 3 times. 19 goes into 19 once and into 38 twice, leaving me at the top with 1 denominator. 3 times 2, 6. That's my answer. If they said with the use of a calculator, or basically they didn't say anything, then you can just take, oh, let's do this again. You just take this whole thing, 2 plus 3 to the power of negative 2. and get your answer. Okay. Next question, still with addition and subtraction. This one here is going to be using my exponent laws. 3 to the power of x to the power of 2 gives me 3 to the 2x minus. My 9 can be written as prime basis. If you didn't know that it's 3 to the power of 2, or maybe you stressed out in the test and you forgot that, 9 equals shift fact. Okay, so it's 3 to the power of 2 to the power of x minus 1. Same thing here, 3 to the power of 2 x minus 1. How come I can't cancel this with this? They look exactly the same. The problem that we have, minus sign in between, so we can't cancel. Anyway, let's continue. 2 times x, oh, that should be a 3, sorry, 2x. 2 times negative 1, negative 2. 2 times x, 2x. 2 times negative 1, negative 2. Let's highlight my negative. Alright, can you guys see? Oh, no, wait. Almost there. I'm going to split it because I like to do that. 2x times. But if you don't like to do that, do you have to show the step? Nope, absolutely not. You can jump as many steps as you want to in between here, okay? You don't have to do as many as I do. This one, common factor. Okay, do I have to take out a common factor in the denominator? No, because this is just multiplication. There is no common factor. If I take it out from here, oh, I forgot to highlight that for you guys. What would I be left with over here? 1, because it's basically this divided by this gives me 1. If I take it out from here, I'm left with 3 to the power of negative 2 over 3 to the power of 2x times 3 to the power of negative 2. Can you see? Oh no, I wasn't using it. Can you see this? And this can cancel out because we now have multiplication. It's multiplication over here. It's multiplication over here, so we can cancel out. Okay, if it says without the use of a calculator, this is going to be 1 minus 1 over 9 over 1 over 9. All right, because this here is 9, okay, 3 to the power of 2, and because it has a negative, it goes to the denominator. Same thing there. This here is 9 over 9 minus 1 over 9. LCDs. This 9 minus 1 is 8 over 9. Alright, and the pin times 8 over 9 times 9 over 1. Cancel, giving me 8. Otherwise, you type it in on your calculator. And we're done with that one. Almost done with this video. No, I lie. Sorry, I have multiplication and division for you guys. This one, a little bit more complicated question. Okay, we need to get them to prime bases. So 32 as prime bases is basically 2 to the power of 5. You can test it on your calculator by using shift fact. It's to the power of 3x over 5 plus 64 is basically 2 to the power of 6. You can test it on your calculator. It's x plus 2 plus 1 over 2 all over. 243 is 2 to the power of 4. I'm just going to double check that. Oh, it's 3 to the power of 5. Why did I say? Oh, clearly I'm tired. Sorry. 3 to the power of 5. No idea why I wrote 2 to the power of 4. 3 to the power of 5. 1 over 5. 8 is 2 to the power of 3. Okay. We're going to now use our rule where we multiplying. So 5 times 3 over x gives me 3x plus 6 times x over 2 gives me 3x. 6 times the half gives me 3. You can test that on your calculator. Okay, 5 times negative 1 over 5 gives me negative 1 times 3 times x gives me 2 to the power of 3x. Okay, what's the problem? The problem is this plus sign. I'm going to split everything up like I usually do. Okay. And And I'm going to highlight my common factor for you guys. There it is. Do I need to highlight the bottom one? No, there's no common factor in the denominator. It's just one whole number. Take this out as a common factor. I'm left with 1 plus 2 to the power 3 over, cancel, cancel, because it's multiplication. Alright, 1 plus, this is 8, so 9 over, this becomes 1 over 3. Dip in times, so 9 times 3 over 1, isn't it? Which is 3. 27. Okay, multiplication and division. Alright, over here, remember you cannot multiply this 2 into the bracket, okay, because of BODMAS rules. Instead, we have to distribute this negative 3 into here and here because there's multiplication. So 2 times a to the negative 3, negative 2 times negative 3 giving me positive 6, 2 times negative 3 giving me negative 6, times a to the power of negative 6 and b to the power of negative 6. This here, because the 2 is in the bracket, it also gets squared, so 4b to the power of negative 12. I'm just multiplying. Now with this here, we can add and subtract the exponents because the bases are the same. So I'm first going to deal with this. 2 goes into 2 once and into here twice. This is different from addition and subtraction one, right? You can just cancel out. This here, I'm going to write the step. You do not have to write it. You can mentally calculate it. It's basically a to the power of 6, right? Minus 6. Why minus 6? Because we add in this one and this one because it's multiplication and the bases are the same. Okay. Then it's b to the power of negative 6, right? Minus the 6 minus negative 12. Why minus negative 12? Because it's division. That's why this minus, and it was a negative 12. So that's why this minus, right? Which gives me 6 minus 6 is 0. Anything to the power of 0 is 1. Okay. Negative 6 minus 6 gives me negative 12. This negative and negative gives me a positive. So it's negative 12 plus 12 giving me 0. Anything b to the power of 0, anything to the power of 0 is 1. So my numerator is left with a 1 and my denominator is a 2. We're done. A super complicated one. Oh no, it wasn't so complicated, but yeah, complicated one simplifies to 1 over 2. What about this one here? We need to get the bases to be the same. 12 can be written as 3 times 2 squared. Let's double check if I'm right. 12 equals, yeah, 3 times 2 squared. So 2 squared times 3. It was to the power of n plus 1. 9 is the same thing as 3 to the power of 2. 2n minus 1. 36. What would that be? 3 squared times 2 squared. Yes, 2 squared times 3 squared. 2 squared, 3 squared to the power of n from there. And 8 can be written as 2 to the power of 3. And it's to the power of 1 minus n. Now we can multiply, because it's something raised to the power to another power, we multiply the exponents. So 2 times n, 2n. 2 times 1 is 2. Times 3n plus 1 from there. Times 3, 2 times 2n, 4n. 2 times negative 1, minus 2. 2 to the power of 2 times n, 2n, 2 times n, 2n. Oops, sorry. 2, 3 times 1, 3, 3 times negative n, negative 3n. Now we can add and subtract the exponents because of multiplication and division of bases. I'm going to put the 2. I have 2n plus 2 from this one. Anything else with a 2 in this row? No, but there is a minus 2n from here, and then there's the minus this here, minus 3 minus 3n. So you notice I put it in brackets. Then for the 3, there was this n plus 1 right? This and this is multiplied, so we can add. So plus 4n minus 2 from here. And then there's this one here that we have to deal with, so minus 2n. Okay, now we're going to add and subtract like terms. So I have got 2n minus this 2n, it's gone. Minus, and a minus gives me a plus, so I've got 3n. Then I got 2 minus 3 giving me negative 1. Okay, 3, I got n plus 4n giving me 5n, 5n minus 2n giving me 3n. Did I do that right? 1 plus 4 giving me 5, 5 minus 2 giving me 3. Yeah. Then I got 1 minus 2 giving me negative 1. We dealt with that, negative 1. And that is our answer. You can leave it like that. If you wanted to, you can take that negative 1s to the denominator by doing this. This is 2 to the power of 3n times 2 to the power of negative 1 times 3 to the power of 3n. So you can take this one and this one to the denominator. Okay, right. You can even simplify this further. This is basically 2 times 3 to the power of 3n if you wanted to. 2 times 3 is 6 if you wanted to. Otherwise, if you leave it like this also, perfectly acceptable. Alright, and I'm done with this video.